Okay, so today we're going to be doing a one-step equation review. This is something that we've done before, and you'll probably remember a lot of it. The lesson outline today, we're going to do the one-step equations involving adding or subtracting. Then we'll have a mind break, which I know Addie will have planned something really great for you. And then we'll review one-step equations with multiplication and division. To solve a one-step equation, we have to perform the inverse operations to move terms to isolate the variable. So you'll remember inverse means the opposite. So if we're adding, we're going to subtract, and if we're subtracting, we're going to be adding. Isolate means to get the variable by itself. And that's what we need to do in order to solve the equation. For one-step equations, identify the operation, isolate the variable through inverses, so you get rid of what is added or subtracted, or you get rid of what's multiplied or divided, and then you substitute your solution. So now we're just going to be focusing on adding and subtracting for the next few problems. Substituting the solution means that you can put your answer in place of the variable and do the problem and see if your answer is correct. So the first example we've got is 5 minus x equals 19. So identify the operation. If you said the operation is subtraction, you're right. Isolate the variable through inverses. So if it's subtraction, the inverse is addition. Substitute your solution. So let's try this problem. X minus 5 equals 19. So since we have a negative 5, we're going to add 5. But the important thing to remember is we've got to do it to both sides. So if we're going to add 5 on the left, we have to add 5 on this side as well. So this cancels the 5 on the left side of the equal sign. And then we're going to add this. So 9 plus 5 is 14, carry the 1, 24. So x equals 24. Now, if we're going to do the solution, we're going to substitute 24 minus 5 equals 19. 24 minus 5 is 19. So 19 equals 19. So that's your proof that you got the right answer. Do you know, I hope some of you noticed that I forgot to circle the answer. So here is the answer to the problem, and this is where we have done our substitution, and that's the answer to that. Okay, here's our next example. X plus 10 equals 20. Identify the operation. This is addition. We're going to isolate the variable through the inverse. So we're going to use subtraction since we have addition, and we're going to subtract 10 here, but we have to do it to the other side as well. So we're going to subtract 10 here. This one cancels. On this side we have x. 20 minus 10 is 10, so x equals 10. Now if we do our substitution, we're going to have 10 plus 10 equals 20. 10 plus 10 is 20 equals 20. So there is the proof that we have the right solution. Now we have a few problems for you to do, and we've just done a couple, so you'll know how to do these. So just pause and do these, and we'll come back in a moment and do them together. Okay, we're back, and let's see. how well you guys did with this. So if we have g minus 5 equals 14, we're going to have to, we know this is subtraction, so we're going to have to add 5 here, and we have to add 5 on the other side of the equal sign. Now, I want to remind you that if it helps you, draw the line down the equal sign so that you can more easily see both sides of the equation. I know that that sometimes helps if you can just split it up so that you know where you're going to be doing the other process, okay? So we've got g, this cancels, g equals 19. So now if we substitute, we will have 19 minus 5 equals 19. Equals 14. 19 minus 5 equals 14. So 19 minus 5 is 14 equals 14. And there we are. So g equals 19. V plus 22 equals 98. Here we have addition, so we're going to have to subtract. So we're subtracting 22 here, that cancels. 22 here, and that will leave us with V equals 76. So now we will have V plus 22 equals 98. 76 plus 22 equals 98. We have 98 equals 98. So we know that our answer is correct. 33 plus j equals 56. This is addition. So we're going to subtract 33 and subtract 33. Now this one looks a little different from the other problems, but we still solve it the same way. So we've got those canceling. That leaves us with j, and 6 minus 3 is 3, 5 minus 3 is 2. So j equals 23, but let's be sure. So 33 plus 23 equals 56. We've got 56 equals 56. That's our solution. Back check so we know that we got the answer correct. Number 6, y minus 33 equals 40. We have a negative 33, so we're going to add 33 to this side, and we're going to add 33 to this side. So now we have y equals, because those two cancel, y equals 10 minus 3 is 7, 4 minus 3 is 1. Oh, sorry. So this one cancels, and then we have to add 33 to the other side. So we have y equals 73. Sorry, that looks a little messy, but the answer is 73. Okay, so we're going to do this. Well, we think it is 73, so let's just back check and make sure. So now we've got 73 replacing the y, minus 33 equals 40. We have 40 equals 40. So we know that our answer is correct. So remember that it may seem to you that you can just look at the equation and figure out the answer, but that's not the point. We want you to solve these using math rules, inverses, and as you go along, your equations are going to get more challenging. So if you get used to trying to solve it without doing the math rules, using the math rules, then you're going to find yourself making mistakes. If you use the math rules, you have a way of back checking to make sure that you get it correct. Now, it's time for our mind break.
Sassy, right? She's a Cocker Spaniel Chihuahua mix, sporting her unicorn outfit. She has her unicorn headband and her skirt with her curly little tail. All right, come on, walk that runway, Sassy. Ooh, come on, Sassy, you can do it. You can do it. Yeah, look at her go. She's waiting right here for her snack, right before she continues. All right, she's a very, very smart dog. She knows what she wants, very confident.
Come on.
She's saying that pepperoni is way too far away.
Let's go. Come on. Come on.
Come on, Sassy, you can do it. We believe in you. Keep going, keep going.
Come on, Sass.
You almost made it.
Come on, Sassy.
Keep going, Sassy. Keep going, Sassy. You can do it.
Come on.
Come on, Sassy. Come on, Sassy. Think she needs some cheering on. Go, Sassy. Go, Sassy. Come on, Sassy. There's another pepperoni. Are you going to do it? Pepperoni. Are you going to do it? Pepperoni. Are you going to do it? She sat down. Come on, Sassy. Come on, Sassy. Let's go. Come on. Let's go. Uh-oh. Sassy just wants to look pretty right here. Say hi, Sassy. Hi, Sassy. Say hi, Sassy.
Come on. I'm going to give her a little help here. Come on.
Go, Sassy. Come on, Sassy. You can do it. Come on. Come on. All right. No dogs were hard in the making of this. Here comes Sassy again, sporting her U of A jersey. There she goes, number 1, stopping. All right, this is Sassy, 8 years old. All right, all right. Number one, U of A colors. Good job, Sassy. Look at her.
Come on. Come on.
There we go. Good job, Sassy. Yay! Good girl, Sassy. Good girl. Entering the runway is Jasper Casper Franklin Vera Cruz with his little Sunday dress and his little hat with sunglasses. Good job, Jasper. Look at Jasper. Look at Jasper go. Woo-hoo! Go, Jasper. Ooh. There he goes. You see the way you looked at me? Showing us his skills. Good job, Jasper. Good job, Jasper. Ooh. What happened? What happened? Had a little trouble with his little hat. Good job. Waiting for his treat. Yay! Good job. Good job, Jasper. Woo-hoo! Good job. Showing off your skills. Yeah. Okay. Coming up is Jasper Casper Franklin. All right. Here we go. Sporting the Rosie the Riveter look and his little jeans. All right. Jasper's 2 years old. He wants to go back up. He wants to go back up. Come on, Jasper. You can do it. Oh.
Change his mind.
Change his mind. He wants to show you his skills of how fast he can walk the runway. Go, Jasper. Go, Jasper. Good job, Jasper. Jasper wants to go again. Go, Jasper Casper. Woo! Good job, Jasper. Yay! Good job, Jasper.
Okay, Lily.
Entering the runway is Lily.
Come on.
All right. There we go. Good job, Lily, with her sunglasses and her skirt and her little handkerchief. And what does her handkerchief say? Hangry. You're hangry. All right. You want to do it again, Lily? Come on, Lily.
Come on. Come on.
Do it again. Woo-hoo! Good job. Awesome work. Good job, Lily. About to enter the runway again is Lily, right? Wearing her jogging pants and her sweatband.
Okay, come on.
With her red shirt.
Come on. Let's go. Let's go. Show off
Come
your
on
stuff.
up. Woohoo! Look at that. She wears it well, don't you think? Look at her. Look at her.
Woo!
Good job, Lily. Good job. You're working those pants. Good job, Lily. Good job. Woo-hoo.
Want a treat?
All right, coming up the runway is Mocha Amaretto. All right, she is wearing her cowboy hat and her little dress. Cowboy hat because she was born during rodeo, right? Ooh, little mishap here. Let's fix it.
Come on. Come here. There you go. Come on.
Mocha is a toy poodle,
Come on.
miniature poodle. Here we go. Go, Mocha. Good job, Mocha. Woohoo! Fluffy as can be. Turn around, Mocha. Good job. Good job. Look, she wants to do it again. Ooh, good job. Doing it in a dress and everything. Does not like the hat. But look. All right, here comes Mocha Amaretto. Come on, Mocha. Let's go. She's sporting her pink skirt and her pink flower headband. There she goes. Work it, Mocha. Work it.
Come on.
Come on. Good
Good
job.
Okay, one more time. No. Put your headband back on.
Come on, Mocha.
Come on. Let's go again. Come on.
Come on, Mocha.
Come on.
You can do it, Mocha. You can do it. Let's go. Let's go. Good job. Yeah. Say hi to camera. With her little tail. Good job, Mocha.
Okay, see, I told you that mind break was going to be fun. Now back to our one-step equations. So we've already covered one-step equations using addition and subtraction. So now we're on to the part of the lesson that has to deal with multiplying and dividing. Okay. So here are some examples of equations with multiplication and division. If I have 4 or any number next to the variable, what is the operation that we're using? Is it multiplication? Is it division? You're right, it's multiplication because 4 next to x means 4 times x, or 4 times whatever the variable would be. 4x equals 16. So if I have multiplication here, I'm going to have to use the inverse, which is division. So I'm going to divide by 4, both sides of the equal sign. Let's just do this for the first one so that it'll help you remember. So I have 4x divided by 4. Those cancel, so that leaves x. Then I'm going to divide 16 by 4. That's going to be 4. So x equals 4. So let's just check and make sure. So if I have 4 and I substitute 4 for the x equals 16. 4 times 4 is 16 equals 16. There it is, our back check. So our problem is 4x equals 16. So we're going to divide 4x by 4. And when we do that, 4 divided by 4 is 1. So that leaves us with 1x, or just x. 4x equals 16. We divide 16 by 4. We get 4. So we have x equals 4. And then we're going to do our back check. So we substitute the 4 for the x. 4 times 4 equals 16. 16 equals 16. So now we know that we got it right. Let's move on to the next problem. Now we've got a division problem. X divided by 5 equals 10. So here, if we have division, we have to multiply. So we're going to multiply by 5. And we're going to have to do the same thing over here. Now, when you multiply, you may either use the dot or you may use the X. You'll see me probably do a combination of the two. Either one is fine, or even if you use a combination of them, it still works. So 5x divided by 5 will leave you with x. So we've got this, leaves us with the x. Over here we've got 10 times 5. 10 times 5 is 50. So we've got x equals 50. But before we circle it, let's make sure it's right. So if we substitute 50 for the x, 50 over 5 equals 10. 50 divided by 5 is 10. So we've got 10 equals 10. Okay, so this is right. Now we can circle that because we know it's correct. Okay, so we're just going to review here. We're going to identify the operations, isolate the variable through inverses, get rid of what's added, subtracted, or, in this case, multiplied or divided, and then you're going to substitute your solution. So we have 2n equals 20. So if I have 2 next to the variable, it means 2 times n equals 20. So if it's multiplication, I'm going to divide. So I'm going to divide by 2 on both sides. And again, we'll just do this for the first example so you guys will remember you can do that. Okay, so if I've got 2 and divided by 2, I'm going to cancel that, and then I've got 20 divided by 2, so it's going to be n equals 10. But let's make sure that we're right before we circle it. So if I've got 2n equals 20, I've got 2 times 10 equals 20. So we've got 20 equals 20. So now we can circle it because we know our answer is correct. Okay, now we've got 3v equals 27. Again, it's 3 times v, so we're going to divide. We'll divide by 3, both sides. 3 cancels. V equals 27 divided by 3. That's going to be 9. Let's back check and make sure we're correct. So 3 times 9 equals 27. 3 times 9 is 27. So we've got 27 equals 27. So V equals 9. Now we have a couple of examples of division problems. So we've got x divided by 5 equals 7. So we know it's division, we know we have to use multiplication. So we're going to say 5 times 5 and 7 times 5 because we have to do the same thing on both sides of the equal sign. 5x divided by 5 is going to leave us with x, and 7 times 5 is 35. So we've got x equals 35. Just to be sure, let's do that back check. Let's substitute the solution. So 35 divided by 5 equals 7. So 35 divided by 5 is 7 equals 7. So we know we're correct. So circle the answer. Another division problem. x divided by 8 equals 10. Now we know how to do it. We've done it a few times, so we're going to multiply by 8. 8x divided by 8 is x, and 10 times 8, x equals 10 times 8 is 80, so we have x equals 80. Let's substitute the solution. So we're going to have 80 divided by 8 equals 10. So we have 80 divided by 8 is 10 equals 10. So now we know this is correct. X equals 80. Okay, now we have a couple for you to try at home. So pause for a moment and try these two, and then we'll come back and check them and see if you remembered how to do them. Okay, problem number 5. H divided by 9 equals 4. So it's division. We're going to multiply by 9. So we have 9h divided by 9 is going to give us h. And we've got 4 times 9. So h equals 36. So let's do our substitute in our solution. 36 divided by 9 equals 4. And we know that 36 divided by 9 is 4, so we've got 4 equals 4. So circle your solution. Now we're back to multiplication. So we've got 4b equals 32. So we're going to divide by 4. Cancel, so we have b. And we're going to divide 32 by 4. b equals 8. So now let's make sure 4 times 8 equals 32. 4 8s are 32 equals 32. So our solution is correct. Okay, back to division. So now we've got to multiply. We've got u divided by 12 equals 2. So we're going to multiply by 12 on both sides. We have 12u divided by 12 equals 1u, and 2 times 12 is 24. So our answer is u equals 24. Let's substitute. 24 divided by 12 equals 2. 2 equals 2. We know this is correct. Circle your answer. Multiplication again. So we've got 20x equals 60. So we're going to divide by 20 on both sides. 20x divided by 20. That will cancel, leaving you with x. 60 divided by 20 is 3. So x equals 3. Verify that we got it right. 20 times 3 equals 3, or equals 60. Let's verify that our answer is correct. 20 times 3 equals 60. 60 equals 60. We know this is correct. X equals 3. Now we have some mixed problem practice. So we're going to give you a few minutes to try this yourselves, and then we'll come back and look at them. So pause for just a few minutes and work on these and see how you do with them. Okay, so as you were doing these problems, you probably realized that you have one practice problem of addition, one of subtraction, one of multiplication, and one of division. That's just so that you have the opportunity to practice each type. And a little reminder here, because this is the last slide and we'll be through, this will remind you how to do these and let you know that you may need to practice a little bit more. So the first one is subtraction. So we're going to use addition here. So we have x minus 30 equals 46. So we're going to add 30 to the left side of the equal sign, and we're going to add 30 to the right side of the equal sign. This cancels, so we have x left there. 6 plus 0 is 6, and 4 plus 3 is 7, so x equals 76. Let's back check it by substitution. 76 minus 30 equals 46. 76 minus 30 does equal 46, so 46 equals 46. Back checked, your answer is correct. The next problem is a division problem. Sorry, I'm trying to get ahead of this and get through quicker, so I'm going to go back to problem number 10 now instead of trying to force you to do problem 11 first. So we have 8x equals 64. 8x means 8 times x, so we're going to divide. So we're going to divide by 8. Cancel, so we have x here, and x equals 64 divided by 8. X equals 8. So let's verify that. 8 times 8 equals 64. 8 times 8 does equal 64, so we've got 64 equals 64, so 8 is your solution. Now to that problem I was so anxious to do. So we've got c divided by 25 equals 3. So I've got 25 times 25 and 3 times 25. 25 times 25, 25c divided by 25 will leave you with c. And 3 times 25 is 75, so c equals 75. Now let's verify it. So we've got 75 divided by 25 equals 3. And we know 3 times 25 is 75, so we've got 75 by 25 is 3 equals 3. Our answer is correct. Now we have an addition problem. S plus 17 equals 22. So we're going to subtract our 17 on the left, and we're going to subtract 17 on the right. This cancels. 22 minus 7 is 5. S equals 5. So now let's substitute to verify. 5 plus 17 equals 22. 5 plus 17 is 22, so 22 equals 22. We've got it. S equals 5. So now you guys should be able to do your homework. If you have any questions, you can always get in touch with us. Ask us for help.